In this video, we're going to practice chain rule. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Here we're going to be practicing chain rule. Now for this first problem, we want to find the derivative of this function. Now you'll notice that this looks very similar to one of the problems that we did with product rule. However, in this case, this quantity is being raised to the fifth power. Now, in the product rule example, we expanded it out, so we didn't have to use product rule. But here, raising it to the fifth power is going to be a little bit more difficult. So, chain rule is what allows us to find this derivative in pretty short order without having to expand it out. Now, what we've got is we have two functions. We have a function on the inside and a function on the outside. So, first let's identify the function on the inside. Here we've got 4x squared minus 8. Now let's call this a separate function by a different name. Y is already in use, can't use that. And x is, in this case, our independent variable. So we'll use the letter u. And u is often used when we're talking about chain rule. Y, it's just the letter we use. So u equals 4x squared minus 8. Now what that means then is y is equal to, and instead of writing this, we'll just use u raised to the fifth power. Now, we've identified our two functions. Now, the way chain rule works is now we're going to find the derivative of these two. So, if we go over here, so the derivative of this function, u equals 4x minus 8, we're going to write our derivative is du dx. Because in this problem, x is our independent variable and u is our dependent variable. Quick power rule, so 4x squared becomes 8x minus 8, that just goes away. Now here we want to find the derivative of this. Y is our dependent variable and u is our independent variable. So we would write this as dy du. And again, this is power rule. So this is 5u to the fourth. Now in the original problem there was no u, there was just y and there was just x. So what we're looking to find is dy dx, where y is our dependent variable and x is our independent variable. And so the way we arrive at that is we're going to multiply dy du times du dx. And what will end up happening is the du's will cancel out. So we have dy dx, which is 5u to the fourth, times 8x. Now, at this point, we're not done because we still have this u, and u is meaningless because u is not defined as a quantity here. So we have to go back up to here and say, well, what is u? Well, u is this quantity that we started with. So we're going to replace u with 4x squared minus 8. Raise that to the fourth power, and we'll combine the 8x and the 5 to be 40x. And so there is our derivative. Had we expanded this, this would have taken us a lot longer, but thanks to chain rule, if we can identify the inner function, we can do this a lot quicker. So let's look at the next one. One of the difficulties that people have with chain rule is oftentimes when you have polynomials combined with radicals. Now, before we identify the inner function, let's simplify this a bit algebraically. So, here we have the fifth root. Now, the fifth root is equivalent to raising this to the 1/5 power. So let's put this entire quantity inside it. So x to the third minus 1 squared. So x to the third minus 1 is being raised by two exponents, the 2 and the 1/5. Now, when you have two exponents, you multiply them. So we have x to the third minus 1 to the 2/5. Now, having written it like this, it's a little bit easier to say, well, this right here has to be the inside function. Now here in this problem, we're using function notation, f of x, and so we're going to have to use a different function. So g of x is going to equal x cubed minus 1, and f, now f of g is equal to g to the 2/5. So, how do we get f prime of x? Well, we're going to do the same thing that we did up here. Here we multiplied the two derivatives. So first we find g prime of x. And so power rule says that this is 3x squared. And f prime of g is equal to 2/5 g to the negative 3/5. So, to find our derivative f prime of x, we multiply 3x squared times 2/5 g to the negative 3/5. Now let's clean this up a little bit algebraically. We're going to have 6x squared all over 5. Now because this is a negative 3/5, this is going to be in the denominator. This quantity x cubed minus 1 to the 3/5. Now some teachers are okay leaving your exponents in fraction notation, but other teachers want you to put it in radical form. So that's going to be 6x squared all over 5. And it's going to be the 5th root of x cubed minus 1 to the 3rd power. How do we get that? Well, the denominator tells us what kind of radical, so that's the 5th radical. But the 3rd, that tells us that it's still being raised to the 3rd power. So let's look at the next one. So the next one, this again has another radical, but this one is in the denominator to begin with. So let's rewrite this. 4. Now inside this radical we have x to the 5th minus 6x quantity cubed. Now it's a square root, so it's to the 1/2, but because it's in the denominator, it's a negative. So our two exponents here are 3 and negative 1/2. So let's combine them. So we have 4 quantity x to the 5th minus 6x, all of that to the negative 3/2. So looking for our inside function is going to be that. So u equals x to the 5th minus 6x, and y equals 4u to the negative 3/2. So our two derivatives are going to be du dx. So we take this derivative using power rule, and this is 5x to the 4th minus 6. And then this derivative, dy du, equals, so we bring down the negative 3/2, so that's negative 6u to the negative 5/2. So now to find dy dx, we multiply. So 5x to the 4th minus 6 and negative 6u to the negative 5/2. The negative 6 will distribute. The u carries a negative exponent on it. So again, it's going to go back in the denominator. So negative 30x to the 4th plus 36. We got this from multiplying the negative 6 in. And then in the bottom, we take out the u, which is x to the 5th minus 6x. Raise that to the 5/2. Now some teachers are okay with that, but other teachers want it back in radical form. So that's going to be negative 30x to the 4th plus 36 all over. Now because we have a 2 in the denominator here, it's going to be radical x to the 5th minus 6x, and that whole quantity is going to be cubed, or sorry, raised to the 5th. Now some people may ask, well, should the 5th go inside or outside the radical? That actually is, that really doesn't matter. the order of operations preserves, and you would get the same result, whether it's inside or out. So down to number 4, we've got sine to the 4th of x. Now, to be clear about this notation, this is sine of x to the 4th power. This often confuses people because it's this whole quantity that's being raised to the 4th. So this is our inside function. This is g of x. So that's sine of x. And then f of g is g to the 4th. So our two derivatives, they are going to be over here, g prime of x equals cosine of x, and f prime of g, that equals 4g to the 3rd. So using what we've established, we're going to multiply these two. So we have f prime of x equals cosine of x times 4g to the 3rd. We replace the g with sine of x, and I'll move the 4 out front. So 4 times cosine of x times sine of x, and that's being raised to the 3rd. Now, you can leave it like this, and that's totally okay. Some people prefer you to write it as sine cubed of x, like that. Some people much prefer that notation. So let's look at the next one. Next one, here we have y equals cosine of x cubed. Now here, there's no manipulation necessary. Here we can easily identify that this right here, that is our inside function. So u equals x cubed, and y equals cosine of u. So we take each derivative. This one is du dx. Again, x is our independent variable, u is our dependent variable. So that's 3x squared. And then here we have dy du. And so that's negative sine of u. Put a parentheses around that. So to find dy dx, we're going to multiply. So 3x squared times negative sine of u. We'll move that negative out to the front. Negative 3x squared times sine, and we'll replace that with x cubed. And that's our derivative. So hopefully by now you're starting to see that with chain rule, the main idea is to identify what is the inside function, what is the outside function. And all you have to do from there is take their two derivatives separately. So here we've got this function, e of x, that's the inside function. So we have f of x equals e to the x. And so our outside function, oops, that should be a t. My mistake. And then we have h of f, which is tangent of f. So our derivatives over here, we have f prime of t, that equals e to the t. That derivative is itself. And then h prime of f is equal to secant squared of f. And so to find f prime, h prime of t, we're going to multiply e to the t times secant squared of f. And all we have to do here is replace f with tangent, e to the x. Secant squared e to the x. And so that is our derivative for number 6. looking ahead to number 7. Now this one often gets people because people often have a hard time seeing what is the outside function. Well, what's the inside function? Well, it's secant. So u equals secant of x. So what is y equal to? Well, we just take out secant and we're left with e, but we can't raise it to secant, we raise it to the u power. And so the inside part is the exponent right here. So applying chain rule, then du dx, that's equal to, well, the derivative of secant is tangent of x times secant of x. If you saw the previous video that we did with trig functions and quotient rule, you'd remember that. If you didn't, I suggest you go look at that video to see how we came up with that. It's a handy way to remember these derivatives that aren't sine or cosine. And then over here, y equals e to the u, dy du, that's equal to e to the u. So now dy dx, our final derivative, we're going to multiply all of this together. So tangent of x times secant of x times e to the u. And right now the only thing we have to do to simplify is to return secant of x in place of u. So tangent of x, secant of x times e to the secant of x. Okay. So there's our answer for number 7. Now looking at number 8, this one's a bit more challenging. Now let me rewrite this. So we have sine of 9x raised to the 5th power. So what we've got here is, it looks like our inside function is sine of 9x. So let's call that g of x. But looking back at a previous problem, you notice that there's something else inside of sine. And so actually we need to make a second replacement. So I'll just call that h of x equals 9x. So back up to here, g is really g of h. We're going to replace that. We're going to take out the 9x and we're going to put h in its place. And now for f of x, well, it's not going to be f of x anymore. We took out sine of 9x and replaced it with g. That's what we called that function. So what we have is we actually have 3 parts here. We have f of g, g of h, and h of x. Now a lot of people get weirded out with this as though this breaks the rule. Actually it doesn't. With chain rule, you just identify each function. And so here we don't have 2 functions, we have 3. Sine is one of them, raising to the 5th is another, and then multiplying by 9 is the 3rd. But chain rule, the pattern is still preserved. What you do is we just take the derivative of each of the 3 parts and multiply them. So over here, g prime of h, that's going to equal cosine of h. Right here, h prime of x is going to equal 9. And then finally f of g becomes f prime of g, and that equals 5g to the 4th. So now our final f prime of x, we're going to multiply all 3 of these. Cosine of h, let's put parentheses on that, times 9 times 5g to the 4th. Now what we have to do is we have to replace what h and g represent. So what is h? Well, h is 9x, so that's what's going to go there. What is g? Well, g is sine of h, but again, we don't want h, we want x again. So let's put the 9x back in that place. So we're going to have 9 times 5, we'll put the 45, those numbers go out front. Cosine of h of x, we're going to replace it with 9x, times, instead of g to the 4th, we're going to put sine of 9x to the 4th. So there, right there, is how you do chain rule when you have 3 functions and not 2. So now with this last one, here we just have a generic f of x equals g of h of x. And so the way this works is we take the derivatives of the 2 functions separately and then multiply them together. Now, what is our inside function? Our inside function is h. And let's call this something else. So u equals h of x. And so f of x equals g of u. Now when you look at chain rule in most textbooks, you'll see that they'll take out this inside function and replace it with u like that. So the derivative of u is h prime, and the derivative of f of x is g prime of u. So du dx is equal to h prime of x, and then the derivative f prime, and actually that should be a u, there is no x there, f prime of u equals g prime of u. So to get f prime of x, we're going to multiply g prime of u times h prime of x. And we replace the u, so that's h of x times h prime. And so this is the textbook definition of chain rule that you're going to find in most textbooks and online. Now the quick and easy way to remember this is you're going to take the derivative of each function, and as you do, you're going to leave the inside part alone first, but then you're just going to multiply its derivative on the outside. And if you look back at some of the examples that we did, you'll see how that plays out. And so hopefully, as you learn to use this more often, you'll be able to just mentally jump from here straight to here. This is useful when you're first learning chain rule to actually articulate what is the inside, what is the outside function. But as you get better, more of this will become automatic and you can just jump from here straight to here. If you like this video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or other problems you want to see worked out, please type a comment below. If you want to support this channel, click the Patreon link to help keep this going. Thanks so much for watching this, and remember, the only way to understand something is to do it.